Hi guys, we're going to have a recap on kinetic, elastic, thermal, gravitational potential, power, energy equations, and then we're going to do an example which will relate all of the things together. Okay, so let's start off with kinetic energy. So the equation for kinetic energy is E is equal to 1/2 mv squared, right? So m is the mass, which is measured in kilograms, not grams, kilograms. V is the speed, scalar quantity, which is measured in meters per second. And E is the energy, which is measured in joules. Energy can be denoted by this large capital J, and we'll see it for all of these. Okay, so we know that kinetic energy is energy due to motion. So let's have a recap on elastic energy now. So the equation for elastic energy is E is equal to 1/2 ke squared. Okay, so quite similar to the kinetic energy, but elastic energy is a different form of energy. It's to do with compressing and stretching. So let's take a look at the constants in the equation and let's find their units. So K is the spring constant. Now, the spring constant is a measure of how stiff the spring is. It depends spring to spring, and its unit is newtons per meter. Okay? E is the extension, lowercase e, and that is in units meters. Okay, so extension is, if you were to think about a spring attached to a wall with no mass, this is the initial position. And then after a mass is attached, the spring sort of gets stretched. And this stretch distance is the extension E. And okay, so hopefully that makes sense. So that's E there. And that's what we plug into our equation here. And then the big uppercase E is the energy, as before. And it has units joules, capital J. Okay, so now let's move on to gravitational potential energy. So gravitational potential energy is energy due to gravity, and it has the equation E is equal to mgh, right? So like before, m is equal to the mass, and that's in kilograms, not grams. G is gravity, and that is in units meters per second squared. So it's not meter squared, it's second squared. And h is the height. And again, that's measured in meters, like extension. So it's measured in meters, not centimeters. One thing to note. And if you want to think about how you would use gravitational potential energy, think about a ball falling down some stairs or something. That change in height, moving down due to gravity. Okay, now let's have a recap on thermal energy. So thermal energy has this equation here. Delta E is equal to mc delta temperature, delta theta. Okay, so what does this delta mean? The delta means a change in. So there's a change in energy in relation to a change in temperature. So again, as we did before, let's sort of find out what these things mean. Again, we know m is the mass, measured in kilograms. And C is quite an interesting one. C is the specific heat capacity. Okay, so pause the video and let me know what you think the specific heat capacity is. Okay, hopefully you've unpaused the video now. Okay, so the answer is that the specific heat capacity is the amount of heat needed to raise the temperature of 1 kilogram mass by 1 degree Celsius. So that means that the units here are going to involve a kilogram, they're going to involve temperature, and they're going to involve energy. So that means that the units for this are going to be joules per kilogram Celsius. Hope that makes sense. Note that it will involve kilograms, it's going to involve Celsius, because the change in temperature is measured in Celsius, degrees. So remember, this is the change in temperature. Okay, so think about like boiling a kettle or making some pasta. You get that change in temperature and you can work out the energy in these processes. Okay, so now let's move on to power. Now power isn't exactly energy, but power is the rate of energy transfer. So it has this equation which you guys have all seen before. It has the equation power is equal to energy transfer divided by time taken for the energy to be transferred. Okay? And it is the rate of energy transfer. And the units for power, they could be joules per second, because it's joules divided by a second. So they could be but they are more commonly written as watts, so a W. So watts is shortened to a capital W. Okay, hopefully that makes sense. Now let's have an example of relating all these things together. So you have someone, they're doing some chin-ups in the gym. So they're moving a distance 0.4 meters off the ground for every chin-up. It takes them 5 seconds to do one single chin-up. Okay, so, and we know their mass, which is 65 kilograms. So pause the video and let me know how you would work out the power, knowing the mass, the height, and the time it takes to do one single chin-up. Okay, hopefully you've unpaused the video. Right, so here's your person. They weigh 65 kilograms, you know the height, 0.4, and you know the time. Now, the power equation is up here, so it's energy transfer divided by time taken. So that means we now need to calculate what energy transfer is. So we need to calculate the energy. So we have the mass, we have the height. What equation are we going to use? So if we have the mass, we can either use this one, or this one, because they all involve a mass. But we have the height as well. Now the height is not in the kinetic energy, the height is not in the thermal energy, but the height is in the gravitational potential energy. So what we're missing from this equation is G. Now G, we know, is commonly 10 newtons per kilogram, or meters per second squared. Now this newtons per kilogram comes from the fact that F is equal to ma, and in this case A is equal to G. Hopefully that makes sense. So you're going to have mass 65, you're going to have height 0.4, and you're going to have G 10. So then you do, for the energy, is equal to mgh, which is equal to 65 times 10 times 0.4. And if you type that into your calculators, hopefully you should get 260 joules. Remember that energy is in joules, right? So you have 260 joules as your energy, and the time for a single chin-up is 5 seconds. So therefore, you do 260 divided by 5 for your power. Oh, I don't really have anywhere to write this. Do you mind if I just put it there? So power is equal to E over T, which is 260 divided by 5, which should give you 52 watts. And hopefully, if you pause the video and tried it out for yourself, that's what you should have got. So well done anyone that got that. If this doesn't make sense, let me know in class. And thanks for taking the time out of your day to watch my video. Bye!